right, so we're going to start with a quiz. Oh, I'm sorry. We're going to start with a quiz. And last time I told you to bring your notes and stuff like that, homework. I'm going to let you, this is going to be an open homework quiz, but you cannot work together, all right? So I expect you to work by yourself. You can flip through whatever pages you have. If you're using a computer, just stay in your notes. Don't be going off to some random websites looking for answers, all right? Put your name on the top. There's 2 problems, front and back here. One problem on the front, one problem on the back. First problem is a limit. The second problem is for you to find f prime of a. Should be 4 there. Should be 3 there. It's more than y'all need, but go ahead. Did I get them out? Everybody has a copy? All right, enjoy. This is a timed quiz, so I'm not going to let you go for half an hour. I expect this to be done probably in no more than 15 minutes. Is open note open? You can use your homework or your notes for that quiz. All right. All right. We'll talk. Okay. Let's talk about a few things, administrative things first, some things that have come up that I wanted to mention. First of all, the videos that I have online, the ones that, like for the homework solutions, I'm aware that I have made mistakes on those videos. If you look in the comments, you will see any corrections. I think pretty much every correction has been addressed in the comments. So if you see me do something, you're like, what the hell did he just do? He forgot the 2. Most likely it's going to say in the comments, hey, I forgot the 2. I was telling some of your classmates today that back when I made those videos, YouTube used to have the option where I could just add these little bubbles to my videos that would pop up and be like, hey, look it, that's a mistake. And I did all the corrections on the videos, and then YouTube just yanked those all away. So rather than redoing all the videos, it's in the comments, all right? That's the first thing. Second thing is that if you send me a text, right, everyone has my cell phone number. If I don't respond, like within an hour or 2, just send me another text. You know how it is, you're driving down the road, you look at something and life goes on, you forget about it. So just send me another text saying, hey, it's me again, just to remind me, all right? Because somebody sent me a text and then I never replied, and I feel terrible about it, but you know, please help me out, send me another reminder. What else? Okay, the exam, that's going to be on Tuesday, right? Monday is a holiday. I'm only telling you that in case you have another class. You should not have any classes on Monday. It's a federal holiday. And then Tuesday we will have our first test, right? We're going to break up the class into 2 pieces. The exam will take place from 1 p.m. till 2:45. That's a standard length of time for a normal class in a fall or spring semester. Normally it's 1 to 2:40, but I'm going to throw an extra 5 minutes in there. And then after that, there will be a 10-minute break, and then we will continue class from about 2:55 on till the 4:30 to continue lecture. That's what you all voted for. That's what we get, all right? So if you finish the exam at 1:30, then that means you're going to hang out till 2:55. Unless you choose to not come to class or leave and not come back, you'll be counted absent, but, you know, it is what it is, right? Do you have a question? No? Okay. All right. So exam 1 is going to cover everything we've done up to today's lecture, all right? So what we do today will be tested on, which is kind of unfortunate, but that's just the way it is, all right? So that means if you have any questions over anything that I do today, you need to get with me before Tuesday, right? So that means you're going to have to reach out via email, text, maybe I can meet on Zoom with you or something. The review I sent out Tuesday, I think it was Tuesday, might have been Wednesday. I sent that to you already. It's pretty extensive, the review. The one problem I would say to ignore is number 21 on the review, because I did not do anything like that in class. So you can dump 21. Otherwise, everything else here is pretty much within fair game. The answers are not here, and I'll see if I have the answers to this. I don't know if I do. I'll see. I told y'all last time I may or may not provide you the answers. So best thing for you to do is work through problems, and if you have questions, reach out. All right? Let me see. Yeah, I think most of this, I'll know at the end of class today whether or not everything here is legitimate. 32 questions. Your test won't be 32 questions. It's going to be some trimmed down version of this.
So on test day, can we leave and come back at 2:55?
Yeah, like if you finish early and you want to leave and, you know, yeah, because when you finish the test, you need to leave the room.
Oh, okay.
So you step out, you can come back. Just because if I let everyone stay, then as people finish, they'll start talking and it'll start to become distracting. So, all right, so the review has been provided to you, and then what you can use on this test, formulas and a calculator, right? So the formulas are the ones that I provided you on the first day of class. Those are what you're allowed to have. Yes?
And you're not sure how many questions will be?
I don't know how many questions will be there, but what I normally do for Cal 1 class is I make the test, I take the test, and then I time myself taking the test, and then I usually multiply that by 5. So by 5 for Cal 1 usually. I don't know. I figure it shouldn't take you more than 5 times longer than me. Right? I mean, that's just kind of the number that I've used over the years. Yes?
15 minutes on that exam?
Pardon me?
15 minutes on that exam?
Did I do? What?
Because you said that you take it and then multiply the time right by.
Yeah, so I should be able to finish the test in like 20 minutes.
This guy.
Well, I mean, because I know exactly what I'm supposed to do. I know exactly why I gave you that problem. You know, there's no thought process for me other than execute the procedure, right? So for me, it's different. I don't expect that of you, right? So, but at the same time, you have to be efficient. I want you to be able to finish the test within a certain amount of time. So that's the way I make it. So it might wind up being 10 problems. I need to make the test first. I thought I saw another hand. No? No?
What was the answer for number 2 in the quiz?
I'm going to show you the quiz now, all right? Okay, so let's look at the quiz. Let's see how this works. I just uploaded this, so I don't know if this is going to work out good or not.
Me too.
Photos? Yeah, I would think photos.
Oh, I got 0.
Oh, that's not very good.
The first definition. I got the 2.
Let me erase this stuff here. Okay, hold on, chill out. Let me look at it. Hold on. I did it really fast, all right? So hold on. We're approaching from the right. Okay, we're approaching from the right. Okay, calm down, everyone. Yes. All right, so this is correct if I come in from the left. When I made the problem originally, it was a negative, and then I deleted something, deleted everything. When it came back, it was positive. So that's because I had 2 versions of this, and so I thought I was doing the first version. All right, so from the right, let's work through this. You're approaching -3 from the right, so you're coming in from this side, okay? So that's not the correct answer. A number to the right of this is what? Negative 2.999 or something like that. I should also point out that when we take this limit, x is approaching -3 on the top, you get -1, which is a fixed negative number, right? The bottom 3 plus -3 is 0, so you're headed to 0. Fixed over 0, we have to figure out what the signs are. So that's why we're coming in from the left or right here. Coming in from the right, -2.99. Plug that in here, -2.99 into this. Plug it in right there. This, -2.99. So if you do 3 plus -2.99, you're going to have a very small positive number. So this should be positive on the bottom. So you have a negative divided by a positive. You already know it's going to infinity, so negative infinity. All right, that's the first one. Sorry about that. Yeah. All right, so now the next one. I did it both ways. I did it both ways so that we could see the algebra. So we're being asked to find the derivative, right? That's what that means at the end of class last time. We said f prime of a, right? F prime of a, that's the way you say that, represents the slope of the tangent line to the function at the value a. So that means I want to use the definition. Now I didn't write the definition out here. We had 2 different definitions. This is actually, I did the second definition first. So that means I'm doing f of a plus h minus f of a all over h, taking the limit as h goes to 0. Show of hands, how many of you that knew what to do here used that formula? Only a few of you. Okay. So if you do it this way, we replace the x's with a plus h's. That's here and here. And then you subtract from that f of a. So you replace these with a's. That's here. You have to have this in parentheses. And then you have to actually expand that. Do a plus h and square it, FOIL, collect like terms. That's this. Distribute a negative through here, this. Distribute a negative through here, this. A squareds cancel, the a cancels. Everything that's left, which is this and this, has an h in it. Pull an h out, there it is, cancel it out. You're left with 2a plus h minus 1. Let h go to 0, that goes away. You get 2a minus 1. That's the first way you could have done it. The second way is to use the other definition. My handwriting looks terrible because I was using a little pen, and I'm a left-hander, so anyone who's a lefty knows that pens just like smear all over the place. You can see I smeared here. So it's wobbly because I had to keep my hand up off the page. So I'm using this definition now. Limit x goes to a, f of x minus f of a over x minus a. I told you that you're not going to have that for the test, right? I'm not providing either one of these. So I told you I'm not big at memorization. This is what I used to do for tests. Anytime I had to memorize a formula, I would sit there and look at it, and then it's like, okay, test time, put everything away. I put everything away. They'd hand the test out. As soon as the test was in my hands, I'd write the formulas down. Okay, that's what you should do, all right? If you're one of those people who are not sure how you're going to remember that, you're going to have to remember it for at least like 1 minute. You're going to have to remember these formulas and then translate it onto paper. All right, so the difference between these with this formula is that when you plug in x into the function, that's this. You plug in a into the function, that's this. Again, you need the minus, you need the parentheses. And then you distribute the negative through, you get this. And this is where we have some weird algebra. We did one of these in class. You have to move the a squared next to the x squared. And then you have to do a difference of squares here. And then factor a GCF out, or yeah, factoring by, it's like a factoring by grouping. And if you do that, you should get the x minus a to cancel, and you should get 2a plus 1. So, minus 1. Yeah, well, I don't know why. It's right here. I don't know why I put plus 1. So same answer both ways, all right? So don't ask me, what happens if let me look at your quiz, all right? You will get partial credit. That's one good thing to doing the tests where it's free response, right? Your test is not going to be multiple choice, no scantrons. Do they even do scantrons anymore? You all know what a scantron is, yeah? Well, I don't know. I mean, yeah, so the test is free response. So I want to see work. If I can see where you made the mistake, then I can judge how big that mistake is, right? Like the quiz problem, the number 1, where if you come in from the wrong side, then it's wrong, right? But if all of your work is correct based upon coming in from the wrong side, then you're still going to get more credit than someone who just leaves it like blank, or just gives me an answer like infinity with no work, right? Y'all clear? Okay. All right, let's get down to new material. So here's where we are, chapter 2. Yeah, we're about to start 2.2, the derivative as a function. So I think I'll start this with a picture. I'm going to show you the two formulas that we have for the derivative. I'm going to show you the pictures that went with those again, right? So the first version we got, right, the first version of the derivative, what we did is we had a function. We started at some arbitrary point, we called it A, and then the second point, we called that point X, and then the idea was to slide that X over to the A, right? And then just move so you get that tangent line to happen, right? So our limit wound up being X goes to A, f of X minus f of A over X minus A, and this is just simply the slope of the secant line connecting the 2 points together. So rise over run. That was the first way we came up with the formula. The second way we did it, same picture, right? We picked A again as our starting point, our base point, but instead of calling this point X, right, we called it A plus H. So it's whatever that was plus some amount moves you to the right. And then what we did is we wanted to let that go here. So to let this point move this way, we would let H go to 0. If H goes to 0, this gets closer and closer to A. So we did limit, H goes to 0, and then our formula changed, f of A plus H minus f of A over H. And I told you last class, don't marry one of these, right? Be comfortable with both, because sometimes this one's a little easier to do than that one. Sometimes that one's easier to do than this one. I would say personally on the quiz, that one was easier, because it didn't require any sort of factoring that was weird. That one, all you had to ever do was be able to do a plus h times a plus h. If you could do that, then everything worked out pretty nice. But then I told you that moving ahead in the class, this is the one we're going to use more, right? So here's why this is the one we're going to use more. In this formula, I used a, right? In both of these, we used a as our starting point, right? What if we call this, instead of a, some other letter? Like, well, you know what? Before I do this, I'm leaving out something I want to point out. In the problem we just did, and if you look back in the problems we did at the end of class last time, when we use this formula, and a is not an actual number, right? I don't tell you a is 2 or a is 1. I just say a is a. Then when we do this, we usually get an answer, and our answer is a formula that has a's in it. So with, that says with, a's. What was the answer on the quiz? 2a minus 1. That is a formula that had a's in it, right? We did 1 at the end of class last time. I think we did 2 at the end of class last time. And our answers is just some formula with a's in it. And what it does is it allows us to get a generic formula that works with that function that we could use repeatedly over and over and over if someone gave us different starting points. So that gives us a formula with a's. And so does this, right? This would also give us some formula here that has a's in it. So what we're going to do now is try, this is, I've been teaching this for a long time. This is always tricky for people to understand, so that's why I'm trying to think of another way to phrase it. In this picture, we're starting with some function f, right? We start with some function I'm going to call f of x, right? And then what we do is we do this to it, right? And when we do that, we call that finding the derivative. And when we do that, we get what? Some formula with a's, yes? We get some formula that has a's in it. Right? So we start with some function of x, f of x, and then if we want to know the slope of the tangent line at some arbitrary point a, we do this thing called taking the derivative, and we get this formula with the a's in it. Same with this picture. We start with f of x. We do this thing, take the derivative. I'm just going to put der. And then we get some formula that has a's. What we're going to try and do here for this next section is realize that if we come to the second version of the formula and we replace the a with the variable x, right? See, I called that a over here, right? Let's call it x instead. It's an arbitrary number, right? Or sorry, an arbitrary letter. Then this formula changes and becomes x here, right? And the only difference is that my answer is going to be a formula with what's in it now? With x's, right? With x's. And this would change to be a formula with x's, right? With x's in it. So I'm starting with a function that has x's in it, right? It's a function of x, so this should have x's in it. And if I do it this way by changing my a's to x, my answer is a new formula, right? It's not this function. It's some new formula that has x's in it. So isn't this just some new function of x? Isn't it? I start with a function of x. I do this thing called the derivative.